would like to start with a quick poll. Who here is using Maven in their day-to-day? Okay, and who is using Gradle? Okay, so I see both popular. And who has heard of Bazel before today? Okay, good. So welcome everyone. My name is Natan Silnitsky, and I'm a backend developer at Wix.com. And I was part of the task force that migrated all the Wix backend code from Maven to Bazel. And Bazel, if you don't know, is Google's build tool. They build their monorepo with Bazel. They have more than 2 billion lines of code. And they open sourced Bazel a few years ago. And once we did the migration, we noticed a dramatic improvement in developer velocity for our developers. And here you can see an example with one of our larger repositories. With Maven, an average build where some average code change was made. You can see it took 45 minutes. But with Bazel, usually be less than 1 minute to get built. So a few numbers on Wix backend. We have around 250 developers, even more today, and more than 750 microservices, and over 10 million lines of code. That's a large code base, mostly in Scala, but there is some in Java and some in Node.js. And we have thousands and thousands of builds every day. So like I said, we used to be with Maven, and we ran on the CI server with Teamcity. And so we have quite a lot of infrastructure code, and all the other used to be Maven modules depend on it. Now, any single change you did to these dependencies, which was all snapshot dependency, meaning keep getting updates all the time, meant that all of the code needed to get rebuilt. So in Teamcity, there was this huge queue of thousands upon thousands of modules that need to, all the dependency graph needs to get rebuilt. And it took hours to deplete. Now with Bazel, we have all of, on any small infrastructure change, you will only get like a few minutes build time for all of the repositories getting built in parallel on the Google Cloud platform. So today I want to talk about the key features that make Bazel fast, correct, and scalable to from small code base to very large code bases, and what it takes to migrate to Bazel, what you need to do in order to have a successful migration. So with Bazel, you control the level of granularity for your build. So the smallest build unit, you can decide that it will be one source file, one Java source file, or you can do, let's say, divide it to Java packages and have separate definitions of build for every Java package, or you can do the more traditional Maven approach of having larger modules with many packages. So you'll decide to build a set of packages as your definition of build. So with Bazel, the basic build unit is called a target. And targets are instances of rules. So you may think to yourself, what is a rule? Well, basically a rule is a function that takes a set of inputs and produces usually files as output. Now, Bazel is a generic build tool. That means it just has dependency graph on many different rules that you can build anything you like, basically. So you can build a Java library, but also a C++ binary that you can execute, or run a Python test, or execute a shell script. There are many, many different kinds of rules that have been contributed by the open source community for a very large number of languages. And Wix as well has added its own set of rules that it found missing for its ecosystem. So here you can see an example of a rule. We have the Java library rule, and here you see a definition of a target. The target is named A. It's found in a build file in the source tree. So this build file defines all the build units, the targets that will be built in this folder called main Java.com example. Now, for this specific target A, it builds a.java. You can see it's very explicitly defined. You can also define more global scopes and wildcards. And it depends on target C. So you have dependency on C plus a.java, and you get a simple output as a.jar. And if you want to invoke this target, you just do in the command line Bazel build :a. :a means that you're in the current working directory of this build file. So this is shorthand notation. So that was a basic example of a rule. And what other kinds of inputs you can give to these rules? So, of course, we have source files and dependencies that we saw. But also, part of the input is the tool's configuration. So what JDK version you're running and what JDK flags you're going to use, and the operating system which you are running on. So all of this is part of the input for Bazel to decide on execution. Now, this action, a compilation or test, will run inside a sandbox. That means that if you have any kind of input, like some file anywhere that you have not explicitly declared in your configuration, then you have the risk that the build will fail, because Bazel will not find it, as it sandboxes the part of the file system that you have defined explicitly. And also for tests, it will not allow you to go and download something from the internet during the test running. So that means that anytime you run this target, you will always have the same output. That's a guarantee. Because of the sandboxing principle and this deterministic builds, you have hermeticity, so you'll always have the same output. And that basically means you never have to clean your build. I can say from Wix's experience that we never found any reason up until this point to clean any cache or any previous build result. Okay, so another important feature of Bazel, like I said, you can define your level of granularity. So there are basically many, many small targets of build definitions with Bazel. And that means that you have one basic target will be very fast to execute, right? Because there's not a lot of things to do. And also the impact on the dependency graph will be much lighter. So usually with Maven and Gradle, there are more coarse-grained parts here out of the box. So that means that if these small targets don't depend on one another, you can run a lot of them in parallel. And Bazel will try, if you run it on your local machine, it will try and use as many CPU cores as possible. So, for example, and not only does it run compilation in parallel, it runs tests in parallel, and it also runs compilation and tests at the same time. So here you can see that in light blue, these targets have already finished compilation and they started running their tests, and at the same time, their dependents are finishing up the compilation. So you can see here that Bazel really tries to maximize the amount of parallelism it strives for. Okay, so we talked about parallelism. What about the incremental build? So we talked about the sandboxing and isolation. So Bazel will investigate what it has in its local cache. And if you only change a very small segment of your source files, that means that Bazel will analyze it and very quickly understand that it only needs to rerun a very small subset, because everything else is already populated in the cache. Now, that's the local experience, but a very, very cool feature that Bazel has is the ability to send these actions of compilation on tests to a remote worker farm. So this really increases the level of parallelism. You're not bound to the amount of cores on your machine. You can have basically hundreds of workers. For instance, at Wix, we use a Google Cloud Platform, and we run our builds with hundreds upon hundreds of workers, and we see the amazing speed that it entails. Of course, it depends on how much dependency you have in your code. But as long as you have pretty good separation of your targets, you can really gain a lot from it. Now, these remote actions populate a remote cache, and your CI server, whether it's open source or whatever CI server you choose, can utilize this remote cache from build for consecutive subsequent builds. And I also want to mention that this remote execution is an open source protocol. So there are open source solutions out there that also provide remote execution of actions, and actually even other build tools around not only Bazel utilize this protocol, including Pants, which is Twitter's build tool. And so you can also use this remote cache output from the remote execution for your local builds. And additionally, well, usually you will run these actions from the CI machine towards the worker farm. But you can also send these actions from your local machine. Now, there is a trade-off here that you will incur network latency, right? So there's a new experimental feature with Bazel. It's called dynamic execution. So it will run the builds both locally and in the remote worker farm. And it will stop the slower execution, the locally or remote, once the faster one is already finished. So you can have both the benefit of remote execution and local execution and get the best of both worlds here. But this is still experimental state. Okay, so we saw all these cool features. Now let's talk numbers. So like I said, we had one of our larger repositories take 45 minutes to get a local clean build. Now, when we run the same repository with Bazel without any use of any caching, you can see that the number is already dropped to 20 minutes, and that's because of the higher level of parallelism that you have with Bazel. But you're still limited to the amount of cores on your machine. So now that if we send it to the remote execution, you already drop it to 8.5 minutes. And of course, when you run it again after you finish the first one, you see that Bazel only needs a few seconds to understand that nothing has changed, and it will return quickly. Okay, so who will I recommend to switch over to Bazel? So it's not for everyone. We talked about there are a lot of small targets. That means you have a lot of build configurations to maintain. So if you're a small startup starting out, you want out-of-the-box solutions, I would go with Maven and Gradle, which have easier learning curve, and it's quite simple to start. But as your code becomes larger and more complex, and the larger the code base, usually you have more interdependencies. That means that you may decide at one point, I'm starting to suffer from slow build times. Well, maybe I won't run these integration tests for every execution or compilation change. So it's starting to have trade-offs. At this point, I would definitely recommend switching to Bazel, because even though you have a steeper learning curve and you'll have more maintenance to do, you will have the quality guarantees that you don't need to compromise. You can always run the builds on any small change, and Bazel will only run the small subset that needs to get rerun, including all the heavy lift tests. And of course, not only do you need to maintain more build files, you also need to change your code to adhere to the isolation and to the hermeticity principle, right? So it gives you deterministic builds. It gives you correct builds, but you will need to change some of your code for that. For instance, for tests, you need to make sure that you don't just create files anywhere in your file system, right? And just access them, because Bazel will not allow it. So there are trade-offs here, but at some point it's highly recommended to do the switch. Okay, so we saw what Bazel can provide to you, and you may are curious, how can I do this migration? So luckily we have Wix's experience in the migration process. So we have 5 important areas of questions that you should consider. The first is you choose the granularity for the migration. So you have 2 basic options here. You can either keep the Maven Gradle granularity, or you can decide to do a finer grain with, let's say, the package level granularity. So what about performance gains? So with the coarse grain granularity, that means you have bigger targets that you want to execute. That means that you have a lesser degree of parallelism, right? Because less stuff can run in parallelism. And also, any change you do will affect a larger part of your dependency graph. So definitely switching to a package granularity will definitely improve your performance. But what about the ease of migration? Well, if you choose your old granularity, then it's pretty straightforward. You have all the information you need encoded in your Maven and Gradle configuration files. So you just need to do a straightforward translation to Bazel configuration, and you're done, other than code changes that you need to do. But with package granularity, you have to have some tool that first understands your file dependencies, which file depends on which other files, in order to decide on the package granularity and, oops. The screen stopped showing. Sorry? That one okay? Okay, well, I hope it reappears soon. So maybe I should disconnect the cable? No? Okay. So, oh, it came back. So yeah, so you need some tool that will allow you to have the knowledge you need about your dependency tree, which files depend on which other files. So you'll know how to define your package level granularity, but you may even need to have sometimes coarser grain because you'll have cyclic dependencies, right, between packages. Bazel does not allow to have cyclic dependencies, so you have to change your dependency from package level to a bigger scope. And so with Wix, we decided to go for the performance gains and do package granularity. And we created an automatic build tool that we used for all of our repositories. And we used the services of a third-party company called Codota that did the dependency analysis for us. We sent them the source files and the compiled jars, and they gave us the file dependency graph. And then we could do, with the migration tool, all the analysis to decide which build configuration we can use. So this process with Codota was painful. We had to have long cycles, and their index could sometimes be stale because they didn't get an update yet from us. So it was a bit cumbersome. But even though there was some pain points there, the basic automatic migration worked, and we managed to do the successful migration into smaller build units. But we decided that if you want to open source this migration tool, we need to find something better. So we have Exodus, which is still in relatively early stages, but we hope to release it soon. And we managed to move away from Codota and have our own dependency analysis built in to the migration. And I'll show you a quick demo here. So basically we have here a simple Java repository. It's Java design patterns, open source. And we can see here some source file from Abstract Factory module. This is a Maven repository. So what you need to do when you use Exodus is to define the Scala Maven plugin, which works in recompile mode of incremental mode, works with the Zinc incremental compiler. And so, like I said, you use, let me just skip here a little bit. Okay, so use the Scala Maven plugin, which you can configure to use the Zinc incremental compiler. It works both for Scala and Java, and it will help the Exodus understand the file dependencies. So if we run our Maven compilation here, then Zinc will create some dependency output files. You can see here in the target folder. You have the analysis folder, and you have the compile.relations file. We have all of the file dependencies, so both for production code and also for the test compilation. So each test file depends on which other production code file, etc. And then Exodus can use this information in order to decide on the granularity. So now in this recording, I'm running the Exodus, and once it's finished, it created the Bazel build files, and here you can see that, for instance, one of these test targets depend on an aggregate of several Java packages. So Exodus identified that these packages have cyclic dependencies between them, so it decided to create a bigger target. And also, Exodus has to, of course, define all of the external third-party dependencies. So you can see all the third parties for this repository. So now we can we'll run Maven clean in order to not mess up the Bazel build. And once we run the Bazel build, you can see here that it's using all of the cores on the machine. I sped it up because it's compiling protobuf. It's a dependency that I want to remove from Exodus. You don't really need to have that. But so it uses all the CPUs it can. And yeah, it's done. So it compiled all the Java sources. Now we'll see some incremental compilation. And so I'm changing one of the source files. I'm just adding a new line here so that Bazel will understand that source files have changed, so it needs to recompile. And you can see that it's only analyzed and found that only 9 actions out of 229 actions needs to get rebuilt. I deliberately slowed down here in order for you to see this 9 number. So it only took 1.5 seconds to 1.6 seconds to build. And of course, if you don't have any change, it will immediately return when finish the build. Okay, so that was a quick demo of Exodus, and I hope that we get it fully functioning soon. There's still some generalizations to do for specific requirements from Wix, and also a few features around test configuration, but it should come very soon. But you can already see the code and can start playing around with it. Nope. Okay. So that was about granularity of migration and automatic migration. Now, the second thing you need to decide on is the amount of source control repositories. So Bazel, like I said, is used to build Google's gigantic monorepo, and it's optimized for that. It basically compiles and has everything on source dependency and not binary. It runs everything from scratch. And but a lot of companies and organizations have a lot of repositories. A lot of people like to work on spin up a new repository for every single project. And you have a small team working on its own repository, and that's very popular. But I will show in a minute why this can be a bit of a hassle with Bazel, and why you can have a compromise between the two and only have a few repositories in your organization. So let's start. Okay, so if you have more than one repository, you need to have a definition in Bazel for all the source files that it depends on from external repositories. So you define an external Git repository, and the commit or the branch that you depend on, and then Bazel will understand that it depends on this repository, will clone it, and then compile the sources from it. Okay, so we have all these source dependencies between all of these repositories, and we changed some code in one repository. Now we need to think about having all of our builds from all the repositories up to date. So if you have a lot of repositories, that means that on a naive solution, you probably get a lot of false triggering of these repository builds, because not each repository depends on each other. So you'll get false triggering. But if you consolidate your repos, that'll mean you probably have much higher degree of interdependency, so you get less false triggering. And of course, if you have one repo, you always execute build with Bazel. You always do Bazel build // ... That means I will build the entire repository, and Bazel is really optimized to understand only the small changes that took place in that large repository. Now, what about the need to manage external source dependencies? So if you have a lot of repositories, that probably means that the list of repositories changes quite often. People add more repositories, some repositories become stale. So you'll need to have some automatic management system to recognize that a new repository has popped up and you have source dependencies on it, or something like that. So it's a bit of a hassle. But if you only consolidate it like Wix has done to a few repositories, so Wix we had hundreds of repositories, something like 900, and we consolidated them according to domain or section or division group to something around 50. So we have pretty stable amount of repositories, and you can just have a static list of repositories where you keep track of them in a head pointer for the last commit. And you can always make sure, like in this fashion, that you have the latest source dependencies. But why can't we have the one big monorepo that Bazel is optimized for? So we work with Git like most organizations, and Git does not support the scale of Wix's code. And we have over 10 million lines of code, like I said. That means hundreds of thousands of files. So that's really not the performance that Git can support. That means that we could have gone with the Mercurial option or something like that that does offer support for large code bases. But we decided to stick with the Git that we love and have just consolidation effort. We do hope to move to one repo once the virtual file system is area for Git is improved. One of the players here is Microsoft. They have their Windows code base, they have large code bases. So they are working on having Git work with virtual file system. That means that you get much better performance. They still need to work on support for Mac and Windows, but we do hope to move to that pretty soon. Yeah, so like I said, we did this consolidation effort, and it worked pretty well for us. Okay, so the third thing you need to look at is which CI server and remote execution environment you can use here. So you can pretty much work with any CI server, but I decided to focus on two major options you can use. You can either do open source, for instance, or choose the Google Cloud build platform. So, of course, open source, the software comes for free, but you need to pay for Google Cloud. So with Bazel, unlike other CI build tools, you need to have a specialized user interface in order to get per target results, because you build the entire repo and you want to get a more fine-grained look at what's going on. And currently there's no open source solution for such a UI, no Jenkins plugin or something like that. But Google does offer something like that. So here you can see the result for one of our repositories, and you can filter the targets according to an area that you're interested in. You can also see which targets have failed or how broken. So this is pretty convenient. Otherwise, you have to look at a very long log file. What about the build server dashboard? So with Google Cloud, it's still a pretty immature product. Basically, they just have one view with all of the build history, and you can filter according to which repository you're interested in. So this list contains all of your organization's repositories and all the branches, so you need to filter according to master branch if you want to see master builds, So it's not very convenient. And of course, with Jenkins, for instance, you have a rich dashboard, and you can add all kinds of plugins. And other CI solutions are also better at this set of features. We also saw today with the Gradle, they have a very cool UI on top of the build scans that Mark has shown. So Google are working on improvements in that area. I think by the end of the year, they'll have a better product. And what about remote build execution that I described before, that you send all the target actions to a remote worker farm? So there are all kinds of open source solutions because it's an open source protocol that anyone can use. But they're still immature, and you have more stuff that you need to configure and think about. And at Wix, we decided to go with Google on this CI server. And they have the remote build execution product, which is currently in alpha. But we're very, very happy with it. It's very stable. And like I said before, we never saw any reason we need to clean the cache. And they have a very cool feature where if you have compilation, which usually doesn't require expensive machines, then you can tag it so the RBE will run it on inexpensive machines, and the integration tests that need more CPUs, etc., will get higher Docker resources for those actions. So you can keep your costs down. So yeah, so Google's still work in progress here, but it does keep improving. Okay, so the fourth thing you need to think about is the local dev experience. Very important to have our developers happy. Now, I have to say that this is quite a painful point for our developers after the migration from Maven to Bazel. There were a lot of pains. So I'll go over a few of the concerns here. The first is utilizing the CI remote cache. So, of course, if you're running on Linux and Basel is optimized to run on Linux, developers in Google each of them have their own remote machine to execute, which is on Linux. So they have limited resources with their data centers, etc. So you can utilize the CI cache with your Linux distribution, no matter which Linux distribution. But it's not the same case with Macs. So the Bazel code base really and design, it's really important for them to know that the build is accurate and deterministic. So once it's configured with different operating systems, you say, no, you can't utilize this remote cache because it's on a different platform. And Mac doesn't have, so with Macs, you need to create a separate cache. That means that either you have your developers populate the cache themselves, and you need to have configurations to make sure they don't change the JDK version that they use. So it's a bit more fragile, but you can have checks in place. Or you can have a separate CI server on Mac Stadium or something like that that will populate the builds, but of course that's more expensive. Okay, so what about compilation? Well, it works pretty much the same way in Linux and Mac, especially if you do have that separate cache. If you don't have a cache, that means the first run will usually suffer, and only once you get it started, the local cache will get populated, and you'll have a good experience on Mac native as well. Parallel testing. So, like I said, there is sandboxing and isolation of networks with Linux with the user namespace features. So you can run all the tests in parallel and have no worry. There is Mac sandboxing solution for file system, but nothing really for network isolation. So that means they will get port collisions and all kinds of issues. So at Wix, we had to have the configuration where unit tests run in parallel, but integration tests have to run sequentially. So that slows down the execution locally on Macs. And IntelliJ support. So Bazel has plugins for IntelliJ, Eclipse, etc. And there are small differences between Linux and Macs, but the plugins do support both operating systems. So we thought we will solve this issue with Mac support by running Bazel inside Docker with a Linux container. But no matter how hard we try to get it to work seamlessly and as if it's running natively on Linux, either the performance was really degraded or the accuracy. So you have all kinds of file system syncing possible, NFS or some Docker for Mac syncing or the Samba protocol, but all of these are not reliable enough. So IntelliJ had issues with the files that it needed and needed to get synced from the Docker container. And we did manage to get stable builds using rsync, but then the performance got hit because with rsync you first need to see that all the files were synced properly before the Bazel build can finish and IntelliJ can update and re-index. So that means for large code bases, the developer needed to wait a long time. So that was a big issue. So we decided this just won't work and we'll stick with the native Mac development. Other companies do have running Bazel remotely. I mentioned Google, but also Databricks has a solution. But that means you won't have the IDE integration. So you won't get the file syncing that IntelliJ needs to re-index all the outputs and get the navigation that we love and the refactoring that we love. So until Mac has a good network sandboxing solution, this is the current state. Good. So that was local dev experience. And finally, very important as well, third-party dependency management and version resolution. So Bazel is optimized for one version for each external jar in the repository. You define external definition of dependencies, which get downloaded first, and then you have a snapshot of all of the external dependencies, and now you can safely build and execute tests in a sandbox environment. So everything that is external is defined in one place in fetch phase before build phase. That's how Bazel is designed. So that means you have much higher contention and possibility of version conflict. So that means you probably want to have one version per repository. There is a possibility to have multiple versions per repository, but you will need to encode the version inside the target name. And it will probably not work well with transitive dependency resolution. So we use with Maven and Gradle to have implicit resolution of all of our dependencies, but with Bazel, you have to explicitly declare all of the jars in configurations in order for Bazel to fetch them first before it starts to build. So, and these tools usually, like Bazel Depths tool, will make sure that you have pretty much one version per repository. So you can try and do multiple versions. You probably get a lot of conflicts, and it's more fragile. But the silver lining here is that you should have one version. It means that you will need to have code changes to make your code adhere to the latest version usually. But with Wix not only adopted the one version per repository policy, but one version even for the entire organization, because that means you always get higher versions with bug fixes, with performance improvements, and everyone keep progressing at the same time. You don't have technical debt, and so we do have here and there like outlier teams that decide to work with their repository with the old version. But basically everyone keeps, we have like a potential break on Mondays, and the team will fix what needs to be fixed, will fix their failing tests, and we'll move on. So that's what we chose at Wix. So I think overall it potentially even improves our velocity. Okay, so we did a review of most of the things you will need to do if you decide to migrate to Bazel. And you can see, especially when Exodus will be out, that you'll have all of the tooling in place to do it in semi-automatic fashion, and we'll get it working pretty fast, I hope. Okay, so to summarize, Bazel is worth it. You get faster and reliable builds, no more cleaning your build, and enjoying correct builds for your CI solutions. The ecosystem is becoming better. I didn't mention it, but we also work extensively on improving the IntelliJ experience, that you only focus on your source files, and the build configuration will get updated automatically by all kinds of tools that we're working on, hope to open source soon. So you don't have to think about all these fine-grained configurations. You just focus on your source files. And like I said, the migration is becoming easier as well. So if you're interested to learn more, you can see our migration stories here. The first one is Wix's migration story with a 5-part blog series on Medium. You can also find Redfin's Bazel migration from Maven story, and also a video by Salesforce. And that's it. Thank you very much. So, does anyone have any questions?
Could you scroll back to the slide where you showed the improvement in build time?
Yes, sure. So you mean this one?
Yeah.
Okay.
Do you have a sense how much time out of 45 minutes was spent on the build itself versus on running tests?
Okay, so at Wix we have a lot of tests. We write code in TDD style, writing tests first. And so I think a very large percentage of it will be tests, unit tests, and also integration and end-to-end tests. And but because there are a lot of Maven modules, there were a lot of Maven modules in this repository, that means a lot of analysis needs to be performed also on the dependencies. Yeah, but a large segment is for tests.
Yeah, so my question is, I wonder if you could achieve the same improvement in the build time, just making your tests run in parallel and still using Maven.
Yeah, so...
Is it even possible?
Yeah, so of course you can run Maven in parallel, and gain performance improvement, absolutely. But what I talked about is you have finer-grained targets, and you have a higher degree of parallelism. So that means that each integration test can run in parallel in a much higher degree than with Maven, right? It's not like it's an integration test for all of the hundreds of modules. It's usually an integration test that covers just a few of the models, usually. And with Bazel, especially if you do a small change, that probably means you don't even have to run these tests, right? Because it will understand that, hey, this test code hasn't changed. All of its production code dependencies haven't changed, so I don't need to run this test. So that's the big advantage here.
Thank you.
So, you moved to a bunch of remote workers on Google Cloud. How much does it cost? I mean, not exact numbers, but you know, did they grow?
I'm not sure about Wix. Well, Google, the remote build execution itself is still in alpha, so I don't know if they have. I'm not sure if they have a payment model yet, but I can show you. So you see Google Cloud Builds pricing. It's 120 build minutes for free each day, and then you have these like a cent per minute or something like that for 8 core CPUs. I'm not sure that remote build execution has a pricing yet. Let me see. No, it's in alpha. I don't think they'll have it.
One more question about the execution time. You mentioned that you previously had to spend about 45 minutes to build the project.
Yeah.
Does it mean that you spend this time on building the entire project or just one of the services? You mentioned more than 700 services.
Yeah, this specific repo with these numbers is a repo with hundreds of modules, and this is the time to build all of them.
And then the question, what was the reason to build the entire project with all the services? I don't think that you touch all of these at once, right? Probably you need to rebuild only 1 or 2 or 3. Okay,
so this repository is an infrastructure repository, and if you do a change in one module, I'm not sure. First of all of them have snapshot dependencies on each other, right? So I don't think, from my knowledge of Maven, that it will be easily understand which module depend on which other and only build those. I mean, you can say, I want to build module A, B, and C, but are you sure that you covered everything? I mean, you're not 100% sure. So I guess on the day-to-day, maybe the developers didn't run everything, or they let the CI server to just run them. I'm not sure, but I don't have knowledge that there is a guarantee that you'll know you covered all the dependencies if you choose specific modules.
I see. So you decided that it would be better for you to choose a strategy to rebuild the entire system rather than rebuild some of the modules that you change and
well, it depends on the specific developer and how he works. He can decide to say, I'll run only a few models and let CI server find any other issue. I don't know. It depends.
I see. Thank you.
Thank you, Natan. Have I got your point correctly? That when I change source files and introduce new classes or packages that I'm using, I have to update build files as well?
So if you add some import on some class that is external to the package, to the Java package, that means that if the build target is on the scope of the package, you have to define a dependency on the target of that other package where the class is coming from, right?
Do I
so
have to do that
I'll
manually
show
every
you.
time?
So imagine, so let's say that A and C coming from different packages, then you have to define all the dependencies here, right? Well, what we at Wix are working on is to have tooling in place that will let you just add an import, and you have a daemon behind the scenes that understands, that recompiles and gets like a compilation error and finds the missing symbol in the relevant jar, then goes to an indexing server that tells this symbol, you can have it with this Bazel target. And then it will just add a dependency for you. But otherwise, if you don't use automatic tools, you'll need each time to go and update your build configuration. Yes.
All right, thank you.
My last question would be your personal opinion. If I, for example, run my pet project, does it even make sense to go with the Bazel? Or it's just appropriate only for huge projects with thousands of classes, etc.?
It's a good question. So with a simple pet project, you could run it with Bazel without having too much concern on performance and just say, okay, I'll define one build target for all the source code and let it run, and it will run, execute. You don't have any hassles of maintenance and anything, but you don't get the performance benefits. So you could use Bazel naively, and it will be fast. I mean, it will be easy to maintain. So if you care about performance and you get slow build times currently, then I'll definitely recommend Bazel. Also, if you have in your repository Go source files and Java and C++, then I would definitely recommend looking up Bazel, because you will have one definition language for all different languages at the same repo. So it's more convenient to look at it, and you can build everything at once also with one command. So also if you have a polyglot repository, I would also recommend Bazel.
Thank you.
Okay, any more questions? Thank you very much. One last slide. So one last slide. Sorry. So you can find the slides in SlideShare, and you can also follow me on Medium and on Twitter to get updates on Exodus and on anything new in Bazel ecosystem and about the improvements that Wix is doing in general to improve its ecosystem and maintenance. So thank you.